Ladies and gentlemen, this is your captain Ulrike Kastrup speaking. We are now halfway through our flight and I expect our arrival on Mars on time in 3.5 months. I have turned on the seatbelt signs as we will be passing some meteoroids shortly. Collisions with smaller meteoroids pose no problem for our shuttle. For safety reasons, however, we will be avoiding any larger chunks. As unexpected flight maneuvers may occur, I would like to ask you to return to your seats and keep your seat belts fastened. Thank you very much. In the meantime, we hope you enjoy the next part of our entertainment program.
Welcome to part 2 of our entertainment program. Today we will find out how we have explored our red neighboring planet in the past. What methods have we used? What have we found out? And where does our knowledge about Mars come from? Thousands of years ago, humans already made observations just by looking up at the night sky. The ancient Egyptians knew that there were stars and planets, and they observed their movements across the sky. One of the earliest maps of the night sky was made about 1470 years before our calendar began. It was found in the tomb of an Egyptian architect and government official named Senenmut. Historical reconstructions of the planet's movements have shown that the constellation depicted on the map probably occurred around the year 1534 before the Common Era. The ancient Egyptians associated the celestial bodies with various deities, which is why the map depicts many, but not all of them, as figures. 5 planets were known at the time: Mercury, Venus, Mars, Jupiter and Saturn. Here is where they are on the map. Mercury's position is marked simply by its name, and Mars seems to be missing entirely. Researchers think that the empty boat on the right-hand side on the map may stand for Mars. That's because at the time this constellation occurred, this is where Mars could be found relative to the other celestial bodies. However, it was retrograde. That means it seemed to be moving forward in one direction, then suddenly moved backward a bit, before continuing to move forward in the same direction. This is also called the retrograde motion of Mars. This type of motion occurs once every 2 years. The phenomenon was known to the ancient Egyptians and they documented it in other records as well. Perhaps they were just unsure what this unexpected reversal meant and therefore left the boat empty. But why does Mars have this retrograde motion once every 2 years? To explain it, you need to think of the solar system the way we do today. We have what we call a heliocentric model. The Sun is at the center and the planets revolve around it at varying distances. The Egyptians didn't think of the solar system in this way, so they couldn't find a satisfactory astronomical explanation for this retrograde motion of Mars. The Earth is closer to the Sun and needs less time to complete its orbit than Mars, which is farther away and has a much longer orbit. For this reason, Earth overtakes Mars once every 2 years. And when this happens, Mars appears to move backward and the 2 planets come nearest to each other in their orbits. This is called an opposition. Mars looks particularly large to us during this time. And since it's so close, this is the perfect time to send space probes to the red planet. But we'll get into that in the next video. Now let's take a closer look at this retrograde motion of Mars. In 2018, a photographer took a picture of the same section of the night sky at the same time once a week from mid-April to early November. Then he laid all the images on top of each other to show how the position of Mars in the night sky had changed during these months. Coming from the right-hand side of the picture, it moved towards the middle, wandered back a little and then resumed its original trajectory. You can see clearly that Mars looks bigger during the reversal because Earth and Mars are in opposition. Let's look at a model to understand how this Mars trajectory happens. Here are the orbits of Earth and Mars. Earth is shown as a blue dot and Mars is shown as a red dot. This is what their relative positions are right before Earth overtakes Mars. If you imagine you are standing on Earth and looking at Mars, then you can see Mars in the sky as a small dot before a background of stars. These background stars are called fixed stars, because unlike the planets, they don't move. In this first position of Earth and Mars, we can draw a line to mark Mars' position in the night sky, the way we would see it from Earth. If we let a few weeks go by and draw another line, we can mark Mars' position in the night sky again. Another few weeks later, we reach the moment of opposition and Earth overtakes Mars. If we mark Mars' position in the night sky at a fourth point in time and at a fifth, we can see how the retrograde motion comes about. Retrograde motion is a phenomenon that from the planet Earth we observe in all planets whose orbits are farther from the Sun than our own. But since in reality the planets always move in the same direction, the reverse motion is only an illusion. The invention of the telescope in the Middle Ages allowed many new observations and discoveries about the solar system and especially Mars. In the early 17th century, Galileo Galilei was the first to train a telescope on the night sky. This allowed him to make many new discoveries about the planet's movements. He was also able to discover many new surface structures on our moon and on Mars. He even discovered the 4 largest moons of Jupiter, which are now called the Galilean moons in his honor. But let's go back to Mars. In the decades and centuries that followed, many astronomers continued the work that Galileo started. Telescopes became better and more powerful, allowing more and more surface structures on Mars to be observed. Some astronomers made increasingly detailed drawings and even maps of our red neighboring planet. Christian Huygens was one of the first astronomers who made such an illustration. He was able to see one of Mars' poles and some dark areas on its surface. He observed through the telescope how long it took for the dark spots to appear in the same position after Mars completed one rotation on its axis. In this way, he calculated that a Mars day was 24 hours long, and that was in the 17th century. Maps drawn by other astronomers followed, until finally, in 1890, the Italian astronomer Giovanni Schiaparelli published a very detailed map showing lots of what he called canali. His modern telescope had allowed him to discern lots of straight lines on Mars' surface, and he published this discovery. The Italian word canali was erroneously translated into English as canals, which are man-made, instead of channels, which are natural. This led to the false belief that these lines were canals built by a Martian civilization in order to channel water from the poles to the equator. This fallacy was strengthened by the large canal building projects on Earth that were going on at the end of the 19th century, such as the Panama Canal project, which was in full swing, and the Suez Canal, which had just been completed. The belief that aliens were living on our red neighboring planet held for many decades, and in the early 20th century inspired many directors in the burgeoning film industry. Schiaparelli's map was even used in the 1960s to plan the first missions to the Red Planet, despite the fact that the map's correctness had already been called into question. By then, it was assumed that the lines were optical illusions caused by the telescope's lenses. Nowadays, our discoveries about Mars can also come from calculations made in the form of computer models, for instance. Here's a picture of a model focusing on the movements in Mars' interior. Another source of information comes in the form of meteorites from the red planet. They can be created when an asteroid hits Mars, blasting bits of rock off its surface. These bits can be thrown so far away by the impact that they are no longer held back by gravity and fly away into space. Later, they may collide with Earth. That is, they may fall to the ground and be found as meteorites. You could call them free deliveries of Mars rock samples. To date, only about 215 Martian meteorites have been found on Earth. That's a very small number, considering that 50,000 meteorites have been found in total. Here are 4 examples of Martian meteorites. These specimens are particularly valuable for research. But how can we be sure that these meteorites really come from Mars? This is where our last source of knowledge about Mars comes into play: past missions to the Red Planet. For example, the Curiosity rover measured the composition of Mars' atmosphere, which was then compared with the composition of gases trapped in the Martian meteorites. Their composition was the same, allowing us to be confident that the meteorites really did come from Mars. But the space probes have provided much more besides measurements of Mars' atmosphere. In 1964, Mariner 4 became the first mission to successfully fly past the Red Planet and send back pictures of its surface. This is the first close-up image of Mars. This image, as well as the increasingly better quality images of later missions, made it clear once and for all that there are neither aliens nor Canali on Mars. A growing number of successful missions collected more and more data, which we can use today to make detailed maps and even 3D globes of Mars, for instance. NASA's Mars Reconnaissance Orbiter has made important contributions to the mapping of Mars' surface. It has been orbiting Mars since 2006 and acts as an essential signal transmitter to Earth for many missions that land on the Red Planet. One of them is the current NASA mission called InSight, which ETH Zürich's Department of Earth Sciences is heavily involved in. We will take a closer look at this mission in the next and final part of our flight, in order to be fully prepared for our landing.